So I've kept this discussion very, you know, I've kept it in a very different way. I don't want to talk about too much technicalities, though I'm a data scientist, I'm not a business guy. I don't want to talk too much about the technicalities of it, and also do not want to drift away too much into the business aspects. So what I've done is I'll just talk about in my own experience. When I joined Voot almost 3 years ago, it was my first stint in media. And to be honest, the last 3 years have been very, very overwhelming in terms of the kind of data that we collect, the real-time data that we collect, and the kind of possibilities in terms of how AI can actually change user experience. It's very different from a lot of other industries because this is a directly B2C business wherein every change you make to the product is actually reacted by the user within the next day, if not more. So this talk is just about how I've personally seen video streaming evolving as a business, and how AI and some of the use cases that are very, very relevant to the future. Which change this one. So I'll start by saying that global communication transforming to text to video. It's a very vague statement to say, but in 2010, all the mobile data that was being transferred, 30% of it was video. Until last year, it was approximately 70%, and we believe that within the next 5 years, it would be 75% or 80% of all mobile data that we send or share would be video. I mean, among all of us also, we would have seen that we are more and more reliant on watching video, whether it's Facebook or Twitter or whatever tool we are using, or everybody is binging on Netflix these days. So that's how important video is becoming to our existence. But the challenge here comes in terms of expectations. If any of us would roll back to the 90s and where we were using dial-up connections to connect to sites, and when even text sites used to take 5 minutes to load, and we were fine with it. We used to feel restless, but we're fine with it. These days, when you're watching a video, suppose you are riding an Uber, you take a turn under a flyover, and you're watching a live cricket match, and the fielder is just about to catch the ball, and buffering starts. Then that's the next few moments of our lives. So I think the expectation of the user in terms of buffering, video quality, all these things are becoming more and more paramount because the market itself is becoming very, very competitive. So I think that's the key focus for anybody who is in the video streaming business right now. One part is content, definitely. Your content has to be good, but the bigger and the more important part is how are you actually improving the user experience in terms of ensuring that they get a seamless and a very, very enjoyable experience while they watch the video. The third and the most important, and a lot of people say that the industry might be in a bubble, as happens with every industry cycle. For example, none of us actually know if YouTube is actually profitable or not. Everybody knows that Google bought it at a price, and if they were to sell it today, they'll probably make a lot more money. But the fact is, even Alphabet does not disclose whether YouTube is profitable or not. The kind of infrastructure they have put in is unbelievably big. And we all know, the video rates or the ad rates online are much, much lower compared to what you see on TV or outdoor. So this is a big challenge. In fact, if you look at any of the sites that go to Times of India or any other site, you'll see so many ads on the sites these days that you don't know where the content and what is content and what is actually ad. So those are the three big things. One, the video streaming market is exploding. Second, managing consumer experience. We all talk about 5G, 4G, but majority of the country is still on 3G, and then there are pockets of our urban cities which are also on 2G. So managing user experience, then for the players who are serving the content or making it available to you, they are also just playing the waiting game, hoping that somehow their business model would actually become profitable in the future. Can AI help in this scenario? Yes and no. It can't make the business profitable. Maybe it can. There is some work going around that as well. I'll probably spend a minute on that. But there are other areas where AI can definitely help. I'll just talk about the top 3 areas that I mentioned. One is, can we get rid of buffering? Is it something that AI can help with? The second is, can videos be searched and indexed? Why will it help to be searched? Why search and index would help? Because if I am a video serving platform and if I were to make money from you, the best way is to ensure that you watch my content more and more. One way to do that is, when you are on my platform, I give you videos that you would probably watch. The other is, I always keep feeding you videos, in terms of watch this, watch that, keep recommending you stuff. Or when you're searching for something, make it available to you readily. Or even if I have to show you ads, I show you ads, only those ads which you would want to see. So that would actually make you more engaged. So, and compared to text, wherein indexing and search is perhaps in a very, very mature stage, video is a different ball game, because the way videos are searched and indexed is that the video has to be broken down into a lot of images, and then each image has to be processed and stored and analyzed, and the data and infrastructure cost of that is very, very high compared to the ROI that can be derived. So that industry or that particular part of the value chain is also in a little bit of flux right now. The third one is, can video experience be enhanced? This is talking about how the future of video streaming would actually evolve in terms of what are experimental areas that are going on. Now, coming back to the first one, can we get rid of buffering? The way video streaming happens, and I'll just probably take a minute to talk about it, is something known as adaptive streaming overview. Now, this is very different to the pirated, all the pirate bays of the world, wherein we actually go and download an entire movie and then watch it. What adaptive streaming means is that the original file, say for example, whatever the file was, you encode it in different bit rates. When I say bit rate, just take it in the form of, say, full HD, HD, SD kind of formats. And then when somebody is actually playing the video, depending upon whether he's in 4G or 3G or 2G, the network information is fed back to the video streaming server, and then the server decides whether to change the streaming from 4G to 3G to 2G or vice versa. It's intelligent in itself, but the fact is that it is just basis whatever information is being passed. Now, when we say how AI can actually help, AI can actually help here. For example, as I mentioned earlier, that you ride the same Uber at 9 in the morning, and at that same 9:30 a.m. you hit the side of a flyover where there is no network, and daily when you're watching a video there is a buffering, right? Daily your device detects that the network status has changed from 4G to 3G or a 2G. It informs the video streaming server and starts sending a lower bit rate. Now, what if the tool is smart enough to know that, this particular user, every morning 9:30 a.m., he enters into a deep hole where there is no network. And even before you hit that zone, it starts streaming a lower bit rate so that your experience is continuous. That is how adaptive bitrate streaming, getting intelligent would help. It is already in experimental stages. Most of the players are actually working on it. It works very well when people are actually traveling in tubes or metros. And it helps also in the sense that there would be no buffering. Because if the content is actually fetched earlier, then you would also stream it in real time. It also ensures that, for example, I'll add a layer to that particular person who's going under the flyover. Maybe out of 5 days a week, 2 days, he's a new dad. Out of the 5 days, 2 days of the week, he's working from home on Wednesdays and Fridays. So the tool should be intelligent enough to realize, okay, on Wednesdays and Fridays, this person is on high-speed Wi-Fi at home. On these days, I do not need to change the bit rate. I need to change the bitrate only on Monday, Tuesdays, and Thursdays at 9:30 a.m. when he hits the side of a flyover. The prevalent algorithms in these cases, these are all open source algorithms. ABR is adaptive bitrate algorithms. BOLA, MPC, robust MPC. I won't get into the details of it because I mean everybody can Google and read about it. Why I want to mention it in particular is that these algorithms were built for adaptive bitrate. These are called optical control algorithms, and they were actually initially, when thought of, and not thought of today, they were thought of like 30, 40 years ago. They were thought of from the perspective of controlling manufacturing and chemical processes, wherein one factor was driving to increase the entropy of the system and two other factors were trying to decrease the entropy of the system. And when you wanted to control the entire system in a way which would benefit your outcome, you would probably use a control factor, right? Nobody realized at that point of time that 40 years from then, what will happen is that there are two conflicting thoughts. One is you want to improve the quality of the video that is being served to the user, and secondly, you want to also ensure that there is no buffering. So if you serve higher bitrate, there would be buffering, but if you serve lower bitrate, the quality of the video would be bad. So these are two conflicting thoughts. And for any ML application where there are two or more conflicting thoughts, the way to go is use optimal control algorithms, and some of these are the ones that are generally used. There is actually more work going around it. So what is happening is that when we talk about these algorithms, they are just taking consideration of the network conditions that are out there. Now, as is the case that is happening with a lot of CNNs or deep learning algorithms that we are talking about these days, which not only look at features but also learn from the responses. So people are actually working on reinforcement learning and other algorithms, which is like building a layer on whatever the tool learns from the features, and then feed that response into a hidden layer and improve the algorithm. So what I'm trying to say is that when we look at any research journal these days talking about machine learning algorithms and the improvisations that have happened, you would probably see that there is not much difference between something X and something Y, because X is trying to include elements of Y in it and Y is trying to include elements of X in it. So the concepts of deep learning, which is building a hidden layer, building an activation layer, activation function to trigger those hidden layers, is being gradually adopted in most of the conventional algorithms, and they are being given new fancy names. But the fact remains that eventually, if I think I'll probably talk about OE algorithm here, which is at least by data published by a couple of research journals, is registering 25% more better outcomes than any of the ABR algorithms that we saw on the previous slide. So I mentioned reinforcement learning because one of the projects that is going on, and it is being driven by researchers at MIT, is that they have built a tool called Pensieve, which is already near production, and they have tested it across tubes in New York and nearby regions, and it is giving really, really good outcomes. So I would perhaps say that if we were to make a very aggressive judgment, within the next 3 to 5 years, buffering would be out of our lives. The second use case that I talked about is, and I use the word zillions. It's not a real word, but because just to quantify the quantum of data that we have. Can zillions of videos be searched and indexed? Now the challenge, as I mentioned earlier, is that videos cannot be searched like that. They have to be searched just like an image. So each video has to be broken down into at least 24 or 60 frames, and then each of those images have to be searched and indexed. The algo, you're looking at a flowchart here. I just kept it as a representative one because this is how surveillance cameras actually work. So this is a typical surveillance camera flowchart where there's a video sequence and there's an object detection. And there's an object classification after that. Object detection is broken down into background subtraction, optical flow, spatio-temporal filter. Spatio-temporal filter is perhaps the most complex one in terms of handling. And then object classification is shape-based, motion-based, texture-based, and then you eventually detect a human. It's a very simplistic model, but it began with this. But right now, any video intelligence platform that we are actually seeing right now use this as the basis for object detection. You might actually have seen, I'm not sure if you guys see a lot of videos on YouTube. You also see a lot of overlay ads which are on the video. You might have seen that they have started becoming very, very intelligent. So you might be seeing a car in the video and there's an overlay ad of a car. It happens because somebody detected via an algorithm that there's a car in the frame, and then a request was made to the ad server to serve an ad which has a car in it. In fact, there are companies which actually, while they stream football matches, and when particular player is in the frame, they start selling their jerseys as an overlay. So that's one of the primary use cases. But then the question is, can they be indexed? Can it be searched and indexed? I think there's a lot of open source information around this, and even the bigger companies which have been collecting a lot of user data for the past 20, 30 years are claiming 95, 96% accuracy in image classification. But video is very far off from it. We have to rely on convolutional deep learning algorithms. This is how a typical convolutional deep learning algorithms looks like. I know anybody can go onto YouTube and search and understand in layman language what it is. But essentially what it does is that you define a set of features for any image, right? Once you define a set of features for any image, you try and decipher it. Now, one is you define a set of features, try and decipher it. The other is you build a layer in between. So one is input and then the output. You build a layer in between which is not an input layer, but rather it's a layer which is hidden and it is just learning from your response. So for example, if it's this big cube and we are looking at one particular corner of it, this process that we are seeing is repeated for every small cube within that cube. And with each step, there's a hidden layer that is being built, and that hidden layer keeps on learning from itself. If I were to take a very crude example, so if an image had to distinguish between a cat and a dog, then one way would be to compare the eyes, compare the nose, and then when you see those strands of hair on the nose, you'd probably say, okay, it's a cat. Or you would look at the tail, you look at the body shape. So you probably decipher elements of that image, go back and check with your algorithm what it has learned about a cat or a dog in the past, and then keep feeding it back to it in a looped way so that that classification can be made. The great thing about CNNs is that to an extent, and to a great extent, Google claims that 97% of their images are accurate. Image classification is accurate. I'm not sure if you guys remember, but at some point of time in the past, there was a open source project in which you could go to Google Images and keep on tagging images with metadata. It was like an open source project. You could just keep helping the global image database. But now they are saying that that thing has learned so much that it is 97% accurate. Video, we are not sure, because as I mentioned in the previous slide, spatio-temporal is a big question mark, and if anyone among you is actually very, very excited about doing research, then that's one of the areas to focus on. CNNs are also now being employed in voice, though voice search is anything related to voice, whether we are talking about our Google Assistants of the world. They are conventionally voice being converted into text and then going via the NLP route, but that somehow is not enough. So if you read about any recent journals about NLP, you will find some fancy name of a new algorithm, but it would have elements of deep learning into it. And that's why if you look at some of the devices, whether it's a Google Home or an Echo Dot these days, they're able to understand us much more better than the phone used to understand us, 3 years ago. So CNN's convolutional neural networks is the buzzword these days, but something that was earlier to it were known as RNNs. RNNs is just the same thing as we saw in the previous slide, but the difference is it's recurrent in the sense that it's a little rigid in terms of what it learns, and it just goes back to say 3 steps or 5 steps as you would predefine it. So for smaller data sets, it is perhaps a little bit more accurate than convolutional neural networks, but on larger data sets, it's not that great. So most of the practical applications these days either use RNNs because they have been using it for legacy reasons, or they just want to do something revolutionary and they're just trying to do it. Then there is something known as CDN, which is convolutional drift networks. Drift is again a word that is derived from one of the previous use cases I mentioned, optimal control algorithms. So drift is something that would perhaps pull the algo to one side. So it is exactly the same as we saw in the previous slide of convolutional neural networks, just that it creates an additional layer which tries to pull it into one direction, and then the other one tries to control it, and it is expecting to get better outcome. Both of these are very experimental, but the fact that if anyone is excited about, sometimes what happens is that when you enter the arena of machine learning and you feel that you can perhaps do a lot of work of practical applications, you end up realizing that a lot of work is already there. Oh, so many open source packages and libraries and models. What do I need to do next? Can I actually contribute anything new? The fact is, most of the models and libraries that are there are not accurate. 86, 87% accuracy is nothing. We should aim for 99%, 98%, and that is where all the research that is going into it. And when I say research, we should not only look at what papers are getting published right now, but also what was published in stats and mathematics 20 years, 30 years ago, because all that is coming alive back right now into the MLPs. The third piece, and I've not actually detailed it out much, but when we talk about video experience be personalized, I think that's the next theme. The first one is targeting, and when I say targeting, it means targeting the user with recommendations, targeting the user with advertising, targeting the user with anything. You could target with when they are in a geo location, you can geo-fence, and when they are near a coffee shop, perhaps you can show them ads related to food around. Recommendation engines are a big thing. I think these days they work really well. The most common ones are the collaborative filterings of the world. There are some exotic ones like SVD and all, which some people employ. But there is a maturity to that particular element of targeting. Where we are seeing a lot of innovations these days in targeting is ads targeting, wherein and one of the elements that is actually happening, particularly with online ads, is that the entire business is going into the direction of programmatic advertising, which is open auction and real-time bidding, and then they have all the user data and they keep on serving contextual ads and all those other formats. So targeting is very, very important for revenue generation. As you would have seen of late, particularly in India, YouTube has started serving a lot more ads. Voot, where I work, is primarily an ad platform. Netflix is purely subscription. Hotstar is a blended model. So I think every player is trying to explore how they can actually monetize their business better. But targeting is very, very important, because that is what will retain the user for you. If you're not able to show him relevant content, and if you irritate him with too much ads or too much irrelevance, they'll probably churn away. The second one is ease, and ease is a very layman term, but you would have seen that say, for example, there's a feature called skip intro on some of the videos, right? And some people feel like, oh, this is brilliant because I don't have to watch that 3 minutes of content. Voot does not have it because we don't have intro. But I would say that that's ease. And how the particular player has actually, the particular player in the market has actually implemented that is that it has, for initial set of videos, it was manually done, right? That when a video was submitted, from 0 to the, say, 2 minutes, 30 seconds, it was manually identified that this is where the intro stops and this is where the skip intro button had to be removed, and it was entered as a metadata. Now most of it is being handled by AI, and that is being handled by a video classification algorithm. So that's one of the use cases wherein when you get real-time metadata from the video, you can actually make the user very comfortable in terms of information. One of the competitors, I think Amazon also has something known as an X-ray. If you watch something on Amazon Prime, you'd probably see a drop-down coming down from the left, which gives you information about all the active characters or actors in that particular frame. And that is because they have access to IMDb, and they have a recognition algorithm also built in, and they have mapped both the two. So they do video intelligence, and they hit the IMDb server, and then they identify the particular hero and that put that in the frame. So it's all to enhance user experience, and I believe as we go forward, we'll see a lot more such features coming into play. The third and the most important one is AR VR, and when I say AR VR, we are talking about it's a broad term, augmented reality and virtual reality. But when we say AR VR, we are talking about stuff wherein there is interactivity in the content. Interactivity meaning user participating in the content. There was a recent movie which I think it was Black Mirror released a movie which had I think 10 different endings. If any of you guys saw it, but I think the challenge there is anybody who is already interactive would probably watch play a game, play a video game which is far more interactive than a video. So the challenge here is building that narrative, creating those interactive elements in the video, and then being able to serve across platforms. You cannot play interactive video on television. You have to do it on mobile device. So that's a limitation. So working around those, then making video experience immersive is a challenge, and it would be a challenge for big screen manufacturers in particular, because the only way they can stay in the market is to make a huge gameplay about augmented reality or virtual reality, being able to augment user experience much better than what a mobile phone could do. Revenue models, yes, definitely, that is where all the advertising and other stuff would actually help in terms of but in particular, AI does not have a much bigger play in terms of revenue models. Anything else? Yes, there's a lot that is happening in terms of AI application in videos. I think one of the use cases that I particularly know about is that so one of the biggest elements of video delivery is content delivery networks. I'm not sure if you guys are aware, but Akamai is like the global leader in it. 70-80% of market they have for all the content that is delivered across any HTTP protocol. So they also want to be efficient. So they are building a lot of AI into when a request is received, how it is handled in the most optimal way so that there is no failure. And then there are video serving platforms, and there are intermediaries, there are ad servers. All of them are building AI into their ecosystem so that their failure rates decrease, their ROI improves, their cost of delivery decreases, so that they can sustain their businesses in a much more profitable way.